Okay, question number 8. We've got a second order differential equation, and we're asked to find value. Unusual this one because we've got dx by dt, d2x by dt, and x for a particular value of t. So we just plug those in. We get minus 7.5 plus 2 times 0 plus 1.5 lambda equals 0. And then we get 1.5 lambda equals 7.5. So lambda equals 5. Okay, so now we've got the differential equation, x differentiated twice plus 2x differentiated once plus 5x equals 0. Okay. So we're going to solve, we've got equals 0 here, which is nice, so we're just going to solve the auxiliary equation. So we've got m squared plus 2m plus 5 equals 0. Use a quadratic formula or our calculators. We get minus 1 plus or minus 2i. Okay, so that gives us this general solution of x equals e to minus t times a cos 2t plus b sine 2t. We know when t equals 0, x equals 1.5. So that implies 1.5 equals cos of 0 is 1, so it's just a. So we've got a is 1.5. So we've now got x equals e to the minus t, 1.5 cos 2t. Now I'm going to differentiate it. Differential that, which is minus e to the minus t times the bracket. Using the product rule. Plus times the differential of the bracket, which is minus 3 sine 2t plus 2b cos 2t. Okay, and we know that x dx by dt, equals 0 when t equals 0. So we get 0 equals minus 1.5 plus 2b. The signs will be 0 plus 2b, which tells us b equals 3/4. Okay, so now I've got x equals Alright, so I've done that one. Now it says, given that when t is 4.5, the child is vertically below 0. Evaluate the model. Alright, so we're going to find the x value when t is 4.5, and we're hoping it's going to be close to 0, because obviously it's on the vertical. So t equals 4.5 will give x, we put 4.5 in, remember we're working in radians. It'll give minus 0.0117 meters, which equals minus 1.2 centimeters. And it says evaluate the model. You'd say this is a close approximation to 0. So the model is reasonable. I mean, it's not an exact science, this bit, to be honest. You might decide 1.2 centimeters is unreasonable, as long as you explain why. That's fine. And the refinements, the obvious one is perhaps to include air resistance, some sort of calculation involving air resistance would make it more accurate.